So that. That's regular still six. No, like, I don't, like three is normal, like, you're doing too much, like, it's fine.
Okay, folks. So we got this unit and then one more. Crazy, huh? Time just flies. Let's see. So you know your partner's name? Okay. Well, did you already know their name?
Yes.
Do you already know everyone in this class? Does everyone in here know everyone? I'm just curious. Has it worked out that way?
Yeah.
I hope so. Um, the date, that's a tough one, isn't it? You have to figure out eight. What does that exclamation point even mean? Factorial. So you have to figure out 8 factorial. That's kind of, I know 8 times 7 is, but then you multiply that by 6, and then it's just getting so big. But I guess that's what you have. I guess that's the only way to do that. Lydia, do you have something you want to tell us?
Oh, because it would just, like, you can think things starting with all the way up to 8 and the denominator, same thing, all the way up to 7.
So I have to multiply all the way up to 7? Oh,
And then you just go left with 8.
okay. So you have on top, you have like 8 times 7. Like, I'll say 7 factorial. Are we good with that? Oh, it is frozen. Thank you. Let me pretend like I know how to write. Okay, so 8 times 7 factorial. Is that the same thing as 8 factorial? And then over 7 factorial. And we could just cancel these factorials here. Of course, you could always cancel as long as you're canceling factors. That's factorial. So that's why the answer is 8. And hopefully pretty easily done once you know how to do it. We can see how someone might be tempted to take a lot of time if they don't know how to do this. This unit is different from the rest. There's not a lot of trig in this one. I'm sorry. Yeah, Eileen, I feel your pain. Feel your pain. But there's always a unit circle for you if you want to revisit. So right there with you on the board and in your heart at all times. But this unit, not so much. This unit could also be described as discrete mathematics. Have you heard about this? Discrete math? So everything we've been doing up until now has domains that involve all real numbers. So those are normal functions when you're talking about a discrete function, discrete math. It's where the domain is just whole numbers. And one of the biggest functions that we're going to use or that you would use in discrete math is factorial. 8 factorial makes sense. 3 factorial makes sense. Pi factorial doesn't make no sense. I'm not sure what happened to my grammar over spring break. I left it at home. So factorial is a basic discrete function you can only plug in. Could you plug in any integer? Is that how it works for factorial? Will you check in with your neighbor? What's the lowest number you could plug into a factorial?
Yeah, so maybe 1. Yeah, no, 1. That's the
Yeah. Well, because like, I don't have
Okay. So 1 factorial we know is 1, and that's about as small as we can go, isn't it, for factorials? Or is it? Dun, dun, dun. Could we go lower than 1 factorial? Can we do 0 factorial? No? For now, I'm going to ask you to trust me. By definition, it equals 1. Which seems like, it just seems wrong. Because you multiply all the way down to 1. But how do you do 0 factorial? We're going to answer, well, I'm going to have, this unit will grow in such a way that you're going to be able to answer that question for yourself by the end. But for right now, I'm going to ask you to trust me. 0 factorial does not equal 0. It equals 1. How about -5 factorial? Can't be done. 0 is the smallest number. So the set of numbers that goes into a factorial function is called, what's that set called? The whole numbers. If we start at 1, those are called counting numbers or natural numbers. In any case, we're going to be talking about sequences today. Oh, you're going to love it. I hope. Moving on to arithmetic sequences specifically. Yeah, that's not arithmetic, that's arithmetic sequences, geometric, etc. Counting on day 5. Yes. And then finally on day 6, I heard Kimmy getting excited about this already. Binomial theorem. So you've been exposed to this, I see. You've seen the beauty. A little bit. Okay. Maybe you're just intrigued by the name. Binomial theorem. We're gonna have one quiz. It's gonna be on the 14th, so that's 6 days away on whatever we do today and next time. That's it. And just one test. Just one test this unit. I'm sorry. I'll think about it. I'll put it to committee and see what they say. 2 tests, maybe 3. Depends what the kids they want. Okay, so then I'll try to put that on the calendar for you. Okay, so let's get started. Any questions about this? All right, let's do it. Today's concept is going to be pretty intuitive in general. Some of the ideas are really straightforward, and it's easy to get tripped up in the notation. So pay careful attention to the meaning of the notation, and you're going to sail through. If I have the rest of my packet, that'd be great. It's right here under packet. Okay. Does this help, these table of contents? Just wondering. Mixed results. Okay, so sequence. I think you already know what a sequence is. It's an order of things. There's a first in a sequence. After the first comes the second. After that comes the third. You can't skip anything in a sequence. By definition, sequence has an order of things. We refer to them in this class generally with lowercase letters. Italic if you're typing it in general. But the first term would just be called A sub 1 or A1, or it could be B sub 1. In this case, it's A sub 1. Second term, A sub 2. Third term, A sub 3. And it could be whatever numbers are in our sequence. We're going to fill them in more specific, more concrete numbers. And that dot, dot, dot just means we keep going. Do we have any idea what's here, this blank one? Anyone? A sub. You know exactly what this is because this one is A sub 10, so this one is definitely A sub 9, isn't it? Right? Because they tell us the 10th one, so before that is going to be the 9th term. I wonder what comes after that. The 11th term. Now we keep going, dot, dot, dot. There are no breaks because the sequence. Can you discuss with your neighbor what these other ones are? How would you fill those in?
Yeah. Well, like details here, you don't know. That's sensitive. So I think this is like a session.
Yeah, Amir. Do I have what? I have them, but they're not graded yet. Thank you for reminding me. I'm sorry. Should by next time at least be able to show you them. Okay. Who could tell us how to fill in those other 4? Yes, Eileen. So you studied this before? No, you just know this stuff? And after the N is going to be. Are we good with this? Of course, the next one would be A sub N plus 3. And eventually we would get to like, this has been so picky lately. Would this make sense? A sub 2n. Eventually we get there. Like if n would be 20, then this would be talking about A sub 40 or just double that. And just one more time, what's the one before A sub 2 and what's the one after it? Seems like you're ready to go. You don't want to talk? You don't want to talk about it. So Zach, what's the one before it?
2n minus 1.
A sub 2n minus 1 and after? A sub 2n plus 1. Okay, so that's notation. Here's one specific sequence a sub 1 equals 2, right? This is a first, third without looking ahead. Can you see what the sequence is? It's hard not to look ahead once I say don't look ahead. There's a pattern here. Yeah, go ahead and take a look. These are the first 5 prime numbers. Do primes really start with 2? Is that right?
No, it's.
Yeah, the first prime number is 2. 1 is not prime. So this is a very set order. Sometimes you'll see sequences given in function notation, so a of 1, a of 2, etc. Would a of 5.2 make sense? No, because the function we're talking about is discrete. Only whole numbers go. Okay, so why are there braces here? When do we use braces? Don't say for teeth. Don't even think about it. In math, when do we use braces for what? Sets. So we're just talking about a set of numbers here. So left one is a set, the right one is a set. Right off the first 5 terms. Okay, so a sub 1 equals this, a sub 2 equals. I'll give you a moment to figure out what are these first 5 terms. After you figure out the first one, make sure your neighbor got the same thing. We call in someone to help me out with these. So make sure you're making sense of it.
Oh, and. I think the phone.
Does it make sense what to do with that a sub 1? If you and your partner aren't sure, you have other people around you. I have a name. You guys ready? Lydia, what'd you get for a sub 1? Do we agree? Okay, want to tell us the rest?
And then, well, I didn't finish A5, but,
Okay.
I got, for A2, I got 3/4,
Positive 3/4?
or negative, sorry, negative 3/4.
Okay.
A3, I got 5/6. For A sub 4, I got negative 7/8.
Okay. So let's see if we could just do that fifth one just by looking at what we have here. Is it going to be positive or negative?
Oh, positive.
Positive, and what do you think is going to be on the top? We get the pattern on the top because the next one's going to be top is going to be 9. The bottom is going to be
Yeah.
So I think.
oh, are the bottoms wrong? Yeah, I think the bottoms might be incorrect. So yeah, these I think it was 5/6 though. 5/8 and then 7/16. So now we can see 9.
30 seconds.
30 seconds. Okay, it makes sense that the top is going up by 2, considering what we have here in the numerator of the nth term, or the general term is what it's called. But if this would have been 3n minus 1, I'm just going to go by 3's. The bottom is just a power of 2. And it says, what effect, oh, Lydia, thank you, by the way. What effect does the -1 to the n plus 1 product have on the sequence? It just makes it so it goes from positive, negative, positive, negative. It's called an alternator. Okay, we're good? Cool. Recursive sequences. How many of you have worked with recursive sequences before? A few of you in which class? Amir? Computer science, yes. Does that sound right? Yeah, so here's a definition we have. So a sequence is defined recursively when subsequent terms are calculated by calling upon previous terms of the sequence. This contrasts with the sequence in example 1, which was defined explicitly. Explicitly just means if I want the 100th term, I put in 100. I get it right away. So here's an example of recursive. In this case, it's b sub 1. So the first term is 1. What does this say? This is saying to get a particular term, all you have to do is multiply n by the previous term. Right? That sub n minus 1 just means a previous term. So, and this is just when n is greater than or equal to 2. So if I want the 100th term, b sub 100 equals 100 times the 99th term. Right? If I want the 100th term, I need the 99th term. Does that make sense? So I can't just like go to whatever one I desire. In this case, it says it starts with 2. So b sub 2. That means I'm looking for the second term. This will be equal to 2 times the first term, the previous one. You see the list all 5 up to b sub 5. Make sure your neighbor's getting it. I'm going to call on someone to help me with these.
Yes.
I think you're right.
Is this
You're
like-
right.
Wait, so what is?
Oh, I.
Yeah.
And then I see. Right? You want.
So this one follows here. It's just.
But and in that case, that's true. So we can times up to.
No, because you.
Yeah.
Great.
Yeah.
Oh, wait,
and,
oh, you're.
Use the previous term.
Oh.
Okay,
I get it.
24. I see what you mean. Thank you.
Is it all falling in place? Okay, Eileen, can you help us with these, please? Like, what do you get for the other ones?
So B2, I got 2.
Okay,
B3 got 6.
6, okay,
B4.
okay. Is 24 times 5 is 120. Are we good with these numbers? Any questions? Could we make this a explicitly defined function or sequence?
And it's greater than,
What's that?
and it's greater than, so does B of one not count?
Right, so our recursively defined sequence, we have this expression here, only counts for these. So we have to have something to build on. That's why it tells us B1. For recursion, if you're not given a previous function or a place to start, you can't build anything. So how can we write this explicitly? Shane, do you know?
Just gonna say that you can do n factorial.
Do you see that? It's just n factorial. Let's take a look. B sub 1 is 1. If I don't do any of the work, this is going to be 2 times 1, isn't it? If I don't do any work, this is 3 times the previous term, which was 2 times 1. The fourth term is 4 times the previous term. 3 times 2 times 1. Same thing here. Previous term, 4 times 3 times 2 times 1. So this one in particular could be rewritten as an explicitly defined sequence. We could say that B sub n is equal to n factorial. So this would be explicit. It can't always be done that way. Like this wouldn't just happen to be, oh, this is just factorial. So they can't always be written one as the other. Oh, look at this fun one. Look at that. Have fun. First 8 terms. And keep that. I want to do something else right after this. So keep that right under the problem. Once you get a sub 2, just check with your neighbor. Make sure they got the same thing you did.
Not so much times 10, so 10 is even, so the negative is. Because this a n minus 1 is equal to a minus 1. So I think
I'm not too sure. So really it's true.
You may want to check with people in front of you, behind you, if you're not quite sure.
Right. Like in there.
Would you get
N,
one of-
A and.
The first one for
Not
A2.
an N.
Like
Wait,
A and minus 1, the
I
previous
think
one
what
and
you're
minus
saying-
even. It's like the converse. And you just kind of.
So like-
I saw this video in last place.
A is this one, because to find for way to and then A and minus 1.
Oh, no.
Yeah, you're right.
The first one for A2, and the previous term is A1. And now you get-
It says apply this.
So you plug the previous term right here.
It's like, cause
No,
the.
you're right. It's the
Yeah.
previous term.
One, this is A.
Is A and
or
minus
like,
1 is
this
literally.
is A then.
I thought they were saying like whether this number.
So that's where you're.
That's what I thought.
You were not that.
No, I think
Don't
it's,
have n.
I think it's saying if,
Here,
I think if the value.
the n minus 1, a n minus.
Wait,
Yeah, I got 5.
It's like-
We use that to count one. So you.
Oh, yeah, it's 8,001.
Well, I think it's about-
It's.
Wait, and then where do I put it?
So you know, 5, now, 8,
It's
yeah, plus this one is,
Oh,
and then 10.
and then you get 5, then 5 is odd, so you said
8 is odd.
okay, no, you're right over 31.
One is odd.
Yeah.
Yeah.
Wait,
So 8 has 4.
Yeah, me too.
Yeah.
Should be the and then you
3 is 16, because 5 times 3 equals 12. And you get 4 to.
So- 5.
Wait, what's 8 6?
Did you get it?
Yeah.
For 8.
Then just 2.
After 8, you're at 8.
Then 1. It's like the same number. Because it's even, but you just so like.
Oh, okay.
Are you finding it? Is it working out? You should get a flow going. Once you get it.
Wait.
I'm not sure.
That's right.
Oh my god.
It's like your explanation too. Right, so.
No, divided by
Makes
two.
sense.
Okay, folks, I have a question for you. This a sub 1 equals 10, is that even or is that odd?
Even.
Are you sure it's even? Yeah, we're looking at the 10. Right? It's saying if a sub whatever is even, a sub whatever is odd. It's not talking about n, it's talking about the that 10. So that 10 is gonna turn into 5. Are we good with that? I just need some help. I'm not sure about how to finish this. Henry, were you able to complete this?
Yeah.
Okay. 16.
8, 4, 2, 1, and then repeat.
So if we continue, it'll repeat. Are we good? Thank you very much, Henry. Cold call. Nico. That was a nice response. Could you give me an odd number between 1 and 20, please? 17. Let's do this again with a sub 1 equals 17. And you can blame Nico. You can blame Nico. He made you do this. Yes? Oh, wait, don't call it anything. Is it a question or?
I can see it. Okay, that's, yeah.
So what are we?
A1.
So do the problem again with a sub 1 equals 17. That's called the Nico number.
What's 72 divided by 1? That's like 26.
That's it.
Eight,
right.
so 4.
Oh, we're doing that for all 8?
Yeah.
Ah,
No, it's what he said.
Go until you find a pattern. I'm going to be calling on someone to help me out with these.
Oh, I complete. I thought 10.
Yeah.
was.
yeah, it repeats.
Yeah, it's then it's
And it
the
gets to
same
the
10
yeah.
tries.
Yeah, it goes back.
And then because that's all, 17 times 3, 51. So a sub 2 is 17. Because that's.
We're gonna go to A16.
Right.
A9.
Well, because that's even.
No,
You should divide it by 2. So it'll be 24. That's all.
Yeah.
And then you should put it back.
Divided by 2, yeah.
That's just,
So.
Are you ready?
yeah, that's what I'm saying, it goes back.
Okay. Nico, you started this. Could you continue for us, please?
So, we said 3 is 26. We said 4 is 13. We said 5 is 3. We said 6 is 20. We said 7 is 10. We said is 5.
The rest is kind of a waste of time, isn't it? We already did the rest. So eventually we get back to the 4, 2, 1, 4, 2, 1. Are we good with that? This is an interesting sequence in that no matter where you start, you'll always end up at 4, 2, 1, 4, 2, 1, 4, 2. Why? I don't know. Math and magic. Yes.
Yeah, I was gonna ask if the sequence is a reference to 3x plus 1. Just like that's the name of it.
Oh, I don't know about that. 3x plus 1?
Yeah, that's the name of like the reason why all the numbers are 2.
Interesting. Where did you hear about this?
Oh, it's just like
Okay. I'm gonna have to watch more YouTube, obviously. So 3x plus 1?
yeah, it's called razors.
Okay, thank you. I'm definitely look that up later. So what happens after the first 8 terms, as you already know, eventually there's going to be that repeating pattern. The loop. It's loopy. Hey, let's go the other direction. Instead of going from the equation to the numbers, let's go from the numbers to the equation.
So then 3 times 26. You just.
Yes.
So you're 3 times 26.
If it's 8, it's not about 10.
Oh, like it is.
Yeah.
Not as.
Not as-
I know the bottom, you're adding by 9.
There's a raise.
You guys see what to do here?
Yeah, it's,
Yeah,
it's an n power, right?
Yeah. It's like, first the explicit, it's like separate. Okay, so this is increasing, right?
Yeah, you have minus one.
You're trying
It's
to
like
by
over.
1/2.
It's be a.
You times it by 1/3.
One of these is pretty straightforward. The other one is loopy.
The first one is.
Well, don't, should we speak another line?
We are trying to see.
Oh, you're right.
Or raise.
Explicitly would be a sub n. Four plus two n.
Would you guess an example? Oh.
Does that make sense?
Yeah.
So it's 1 over
It's a reference
4
to
to the n.
Or to.
No, not 4. 2 to the n.
Did you get it? At least the first one?
First.
I want to hear what you did for the first one. I'm interested. So Hannah, how'd it go?
A sub n equals 4 plus 3n.
4 plus 3n. Do you want to tell us about your thought process? How'd you get that?
So it's like 3 times, so for the first one is 7, so it's just 4 plus 3 times 1.
Okay.
And the second term is 10, so 4 plus 3 times 2, which is 6. 4 plus 10 is 6. And it like works well.
Nice. Are we good? Did anyone go through a different thought process to get this or something like to share? Because for me, I would think just like 7 plus 3n and then see automatically that that's wrong. Do you agree? And then I have to adjust. I maybe something like this because I can't start counting n's for a while. So that kind of puts my counting backwards a little bit, which is exactly what you did. And ultimately, it's the same expression that you did. So thank you. But that's definitely preferable, 4 plus 3n. And I prefer that to 3n plus 4, even though it's the same thing. I think 4 plus 3n keeps a flavor of what we're doing. We have 4, and then we're building off of that 4. How about this? A sub n equals... Oh, did anyone get anything different? Like completely different? And how about a sub n minus 1 plus 3? Yes, Eileen?
But that's not explicit.
Exactly. We have to follow directions. So that would be a great answer for a different question. Would this be enough though? That recursive? I have to have something to build on. So in this case, I would have to say that a sub 1 equals 7, and this would have to be n is greater than or equal to 2. So just keep in mind, this is explicit. And this is recursive. So answer the question as it should be. This is our answer. The second one's a little bit wonky, don't you think? Except the top is a very definite pattern. I hope it's easy to see. Yeah, Rihanna, do you have a... Ria, do you have a question? All right, suggestions? Oh, could you talk to us about how you did it, or what is it?
Like a sub n equals 1 over n times n plus 1.
How'd you get that?
Or like I was looking at it. Okay, so the bottom.
Okay.
So basically, so like 1/2 is the first term.
Uh-huh.
6 is the second term.
Okay.
Whatever, like third, fourth.
Okay.
And I compared like n to the bottom denominator because I know that's a thing that has to be changing.
Okay, so in your mind, there was like a little thought bubble with a 1 here, thought bubble with a 2 here. Okay.
The way it got from like 1 to 2, 2 to 6, 3 to 12, 4 to 20. It's also like something I think I've seen before too. So I kind of whatever. But so then I did like how do you get from 2 to like what's like the similarity? So then I just did like 2 times 3, 3 times 4, 4 times 5.
Mhm.
Just times it's like that number times the number right after.
I love it. Does that make sense? Definitely not easy to see, but I like how you thought that this is just the first term. 1's got to be involved, 2's got to be involved, 3's, and then maybe that way we can make that connection. Or just if you're to play with it, and this is pretty much the same thing. 2 is 1 times 2, 6 is 2 times 3, 12 is 3 times 4. And we find the pattern somehow. So nicely done. Okay, before we get into summation notation, I am going to give you until 2:26 to clear up any questions you had. And if you want to stretch or zone out, now's a good time.
You don't get a unit line for something.
No,
That's really fun.
I think it might be impossible.
Oh.
Yeah.
You would have to see multiplying because it's probably right. Because like.
Yeah,
I was
maybe
kind of
possible.
basically, but like 1/2 to 1/6 is like 1/3. Or something, right?
Yeah.
And then 1/6 to 1/12.
Yeah.
I mean, like, both.
I think so.
No, I think they're separate.
You have to use that whole one.
Like one and six.
Yeah,
And then the other one's the other.
You can't like.
Yeah.
It's like 1/2 times 1/3, right?
I think it's right.
But you wouldn't expect.
I would expect.
What you said, oh, you said right down.
Yeah.
Like what should be. This part. Yes. That's the spot.
So did you, that's because I didn't explicit. I didn't, I did refer to.
It was all. Yeah, makes it better for the others. Then I had to go. They're the same thing.
That's just- How you know? Like these are.
Okay, because one of them, I was.
I thought we did.
Yeah, like this. So then I tried out on test.
I thought we did
Serious?
this.
It was better.
So then I heard.
This. This.
Yeah.
First. This part.
Just like.
This.
It's like. Well, these don't, like the one with like,
Yeah.
these don't have like, now this, this whole drawing.
That's. Give you.
I don't know if I did right. Like I know some of like.
I said to say.
That's just like guessing. It's like if you know.
Yeah, you have to write me on this. It's.
Common. You know the one that's like the spiral.
Where it was like if you add.
Oh, I do. Yeah, that's why.
Yeah, no, we don't, we have to sit in the gym. I have friends.
Wait, also ready?
You have a hush on, but it's like we sit in the gym, but it's just like. we-
Yeah, no, I remember.
It's not like a lunch.
That's easier to study towards.
It's a little easier.
Yeah, but are you saying?
So I guess. Actually, what I did, eligible, like, it's, I still don't.
Class literally just started.
So today.
Still got a contract. Eric.
Oh my God, I remember to ask you, Mike, oh my, I don't remember.
You go ahead and wrap up your conversation.
I feel.
So let's finish this up. This next part, things get a little bit interesting.
No, oh, for the. No, it's like.
The summation, of course, comes from the word for sum. We're going to be adding stuff together when we're talking about summation notation. Have you seen this letter before? What is that? It's a sigma, Greek letter for S. So it signifies, not signifies, but signifies that we're going to be adding stuff together. And by definition, this left side is equal to the right side. This is read the sum from k equals 1 to n of a of k. And all it's saying is we're going to add up a bunch of terms of a sequence. What's the first term we're going to add up? This tells you. So a sub 1. How high do we go up? Until we get to the nth term. So if it would have been a 5, we would have just been adding a 1, a 2, 3, 4, and a sub 5. That's it. It tells us what we're adding together. Does that make sense? So when we see this, I'm gonna make it so it's maybe not so desirable to add up. I'll put a square right here. K squared. But before I do anything, would you just make sure your neighbor understands how many terms we're gonna be adding up? here, how many terms are gonna have that? So check with your neighbor. Check with your neighbor.
Yeah, like said to add it, but but don't get in.
So how many terms are involved with this stuff? How many terms? There's four. Right? It's the fifth term, sixth, seventh, and eighth. That's what it means. We start not at the first term. I don't know why, but it's just an exercise. So the fifth term counting up to the eighth. So go ahead and write them all out. Don't add them up and put little plus signs.
Okay. Wait, what's,
Well, we know these.
Wait, how do you?
wait, what's the sequence?
Okay, I just.
It's a random.
Like,
It's quite bad.
Oh, so you just put like 8, 5 plus.
No, just doing
We'll
regular.
plug in the 5, 6, 7, 8.
You guys Edison me. Also, actually.
Oh,
no.
you plug it into, you plug it into.
Right, you
Oh, I
plug
get
in
it, I
five
get it.
for K, right?
Yeah, I think, yeah.
And then seven.
It's just
Okay, right.
16 plus 19.
So it's like 76, cause it's like 5 squared times 3, so 25 times 3. So
Okay, and then let me just.
Oh, you're asking.
Then it's third. Six, plus.
Yes.
I just. Sure. It is.
Oh.
And then there. It is there.
Wait, did I do something? wrong? Oh, I started.
Oh, but I put it in there.
And then plus
Oh.
25.
God.
So it's no longer.
And now we're doing a square.
I,
Oh,
That
it's,
just make
it's,
a little bit more
it's been a square.
So when square does that, so you get geometric?
it's neither.
Oh, it's neither.
So you have the term.
Oh, I see. It's not like, it's just, these are not.
Sort of quadratic.
Got it.
I'm not in.
Okay, that's.
Are we okay with this one?
No, you're.
So this is the game plan. A sub 5, how do I figure out what A sub 5 is?
Plug 5 in.
Plug 5 in for K up here, which means we're gonna have what is that? Oh, maybe I made this too hard. 3 times 5 squared plus 1. That's the first term, and then that sixth term is gonna be 3 times 6 squared plus 1 plus 3 times 7 squared plus 1 plus 3 times 8 squared plus 1. There we go. Calculator ready. Are we okay with that? Any questions? Did you already finish B and C? I'll give you a moment. How many terms are in B, by the way? And how many terms are in C?
1, 2.
Four, 1, 2, 2.
So is it safe to say you subtract? Think of the number of terms, subtract plus 1, subtract plus 1. Because you have to count that first one.
Six.
We'll see what I did. What's the square root?
Oh, okay.
There's just gonna be 1 to 1.
So just make an expression. You're not actually summing them, you're just keeping it as an expression.
Oh, I didn't.
If we, some, or.
That's fine if you do. I'm not looking for that. Okay. Can I call on you? Are you ready? Hey, Noah could help us with B, please.
I didn't like make it like quite sped out, so.
Okay.
Maybe I just say like factorials.
Yeah.
Okay, so I have -1 factorial
-1 factorial.
plus 2 factorial.
Wait, so the first term is -1 factorial? How do you get that?
You put 0 in. Oh, shoot, actually. It's just. Yeah, it's just 1, sorry. It's just
We start with 1? Is that right? We start with 1 or do we start with 0? When you plug in the 0, you get,
Oh, yeah,
What?
factorials, maybe I just.
Okay.
0 on the top.
okay.
Since he didn't want to add it, that's fine.
Yeah.
So we got 1, and then I think you already had the next one.
Yeah.
-1, you're saying? Okay, after that. I'm gonna leave it as just 2 because it's the same.
Then -3 factorial.
Okay,
Plus 4 factorial. -5 factorial. Then plus 6 factorial.
are we good? Right, that -1 serves as an alternator. So once you have the first one, it's just plus, minus. Noah, thank you for that. Holden, do you have a question?
Oh, yeah, so you want us to notate it with the factorial instead of actually multiplying.
Yeah, I'm not interested in you doing the work for this. I just interested in you getting the meaning of it. I know that you could all do this. I hope you could all do it. Especially now that we've come to a consensus that 0 factorial is 1. The rest shouldn't be a problem. And something like, if you see 0 factorial, I do expect you to rewrite that as 1 or 1 factorial. Just rewrite that just as 1. Eileen?
If you write it like not 3 factorial.
Oh, like you would do 6?
Yeah.
Yeah, that's fine. But don't, like, once you get up here, don't get stubborn and say, I'm going to do 6 factorial.
I mean, I just did all of them, so.
Okay, yeah, if you know them.
Do it because it's just like the previous one multiplied by.
That's true, yeah. Good point. So there's not redundancy when you're doing these. Okay. Thank you. Good insight. But if you added them together, if you actually put those numbers together, there'd be trouble. Ria, could you help us with C, please?
So A1, are we playing with actual values?
Yeah.
Got 7.5. I got 12 bits. 17 cents. And then 22 17ths.
22/17. Do we agree? Thank you, Ria. Okay, doing great. Now it does say express each sum using 2 different summation notations. Let's just do 1 first. I'm going to put a line here so we have stuff on the left, stuff on the right. There's a natural one first. Just do 1 for the first one, 1 for the second one. So you're going to be writing that sigma. Yeah, check with the neighbor, make sure they got that first one. Did you finish the first one already? Did you finish the second one already?
Wait, did you say the page?
Yeah, do A and B.
I was thinking two
Just one of them for each. If you want to do a second one, you can.
Okay.
You're fine.
So then I don't know. Oh, sorry, it should be K. Oh, no, it's not.
Well, that's just gonna be one, and it reads like that.
It's
It's
just
just the fact that.
K equals one.
Oh, it's well, it could be
Changes
just two to the first, changes three to the first,
This is what I did.
over.
But
the second, three to the.
I don't.
Yes, like the explanation is increasing.
Oh, okay, so it's
It gives you a pretty big.
two over three.
Yeah, but I don't know if I,
Well,
I didn't use,
I think it's just gonna be,
this one's in 12 now, but
Are we good?
yeah,
That means like.
yeah, to the end.
I did 2
I would-
over 13.
I would think it looks like this.
Just out of curiosity, how many of you is today the first day you're making a sigma in your life? Is today the first day you're writing sigma? Oh, you're writing Cam. Okay. In Camelot. Interesting. I thought that was a fictional place. Camelot? No, no, not funny. Sorry. Okay, I like to write the top one separate so you get that pull away.
Those need a.
I like to have those. You could just do, you just like make it kind of look like an E if you want, whatever you like. I need to know what's on the bottom, what's on the top, what's the argument. Shane, what'd you put on the bottom of the sigma?
The one,
You just one?
or K is one.
K equals 1. Okay, how about the top? Okay, and the argument of it?
I said K over K plus one.
Are we good? Thank you. Yeah, normally we use either K or N for the variable. It doesn't matter which one. X is generally reserved when you have all real numbers. Like K and N are usually whole numbers or at least integers. Okay, and for B, let's see. Levi's not B. Sophia S. Were you able to get B? Okay, what'd you do? Okay. Okay.
Okay.
Okay, plus 1. Oh. I'm gonna be lazy and just change this to N equals 1 on the bottom because too many K's already. But thank you, they do have to match. Does this work? If I'm asking for 2 summation notations, would it be okay to just change everything to K? No, that's kind of slimy, don't you think? It's the same thing, just replacing a letter. That's not what I'm looking for. But this was great. Thank you. Any questions? Yes, Eileen? Oh, for A, why is it 14?
Oh, wait, never mind.
Now, I think that the important thing with this 12 on the -1 is just that it is even. Right? It doesn't really matter that it's 12, so that N plus 1 or N minus 1 would give you the same terms. Yes, Nico.
Do you want us to simplify the 2 long over 3 divided the 2/3 together?
Either way is perfectly fine. Neither one is simpler than the other. And normally, actually, and I don't care which way you do this. Normally, the alternator comes first. So this is what you'll see normally, along with this. But it's either one is fine. You won't lose points if you switch them or if you do them separately. Are we good? Sophia, thank you for your help. That was great. Oh, are you okay reading this? How would you read this? It's not sigma with a little this over here, a little that over there, and this on the side. Although I understand what you're saying.
Yeah, then you got like the bottom number, like below the sigma, the K was 1, that's like how with the first time. With the first base.
That's how you're gonna tell someone? I'm just saying, how do you read this? Oh, it sounds like you're saying me,
First,
which is great.
I guess, and then the top number, the 14, that's like how many terms there are.
Okay,
And then the thing to the right, it's like, I guess it's like 40, I guess. That
Okay.
makes sense.
so that you have the meaning down perfectly, but to read this, you're not gonna tell someone like what it means as you're reading. Like if you're saying sine or something, you're saying opposite over hypotenuse of such and such. Right, it's just that's the meaning of this. Do you want to give it a shot, read?
Is it like for K equals 1?
Right, it's a whole lot of stuff going on, stuff going through words.
It's like a, it's like a phrase.
There is a phrase.
I don't.
Okay, yeah, I mean,
Is it like base?
base K, oh, I go into logarithms there. That's a good guess. Kimmy, do you have an idea?
Maybe the sum of k over k plus one for k equals one for 14.
I think you're getting there. You're getting there. Yeah. The way I would say it, normally, and I'm just gonna wrap this up. The sum or sigma from k equals 1 to 14 of whatever is it really in this case, k over k equals 1. So the sum from this to that of this. Does that make sense? So, I mean, it seems like you all had a clear understanding of what it is, but I just want to make sure you know how to say it, how to communicate effectively. I'm going to challenge you here. The second one, we're going to say we're taking the sigma from k equals 5. Go ahead and rewrite the expression k. It's starting at k equals 5. I just chose 5 randomly. Any integer would be fine. Whole number is better. This is not the natural way to do it, but you could do it.
Oh, it works like first.
Oh, that's how you interpret it.
That's how I.
I just read it as like starting from the term.
Oh.
You got to start from the 1/2.
Oh,
So I,
You're generating that same problem.
like 9.
Yeah, 1/5, 1/2 is the 5th term.
Oh, yeah, you're.
Okay,
So there's still 14 terms. Okay.
we ready? I'm gonna ask for a volunteer for this one because this one's kind of out there. Yeah, Amir, help me out.
So we did 18 on the top, same one.
Okay,
Just did k minus 4 over k minus 4 plus 1.
k minus 4 plus 1. Can I just make k minus 3? No problem. You can make k minus 4 plus 1. So that was a nice way to say that you have the same thing on top and bottom, and you're just adding 1. But you could feel free to simplify. Let's see. Does this work? Does this give us a first term, that 1/2? Perfect. Does it give us the last one? Is it the same number of terms? Are you sure?
Yeah.
To get the number of terms, you subtract and then add 1 to that odd one, the first one. I'm sorry. Well, this is only equals something here. We could say that this whole thing is equal to these fractions that are being added together. Before I move on, I do have a question for you. I'm not going to do a second one for that last one. If I ask you for this, n equals 1 up to 5 of 2. Will you please evaluate that for me? Check it with your neighbor. Don't call out your answer, but check with your neighbor, see what they get.
I'm thinking like.
Well, everything is.
This expression is what you do. I'm just going to see how it's done. So maybe.
For D, What, that's how we.
Yeah, that's study. Goes by time.
Yeah, I think it's clear.
Is that correct? Context?
So all we have today.
Well, it's like for every
Oh.
number, it's.
Take the right side of that.
So it's,
How many terms are there? There are 5 terms. Can you show me what the answer is? Did you get it? The answer? Yeah, the answer is. Right, what we're doing is a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. That's what it means. And each one of these terms, they're all 2. They're not dependent on n or k or anything. So this is just 2 plus 2 plus 2 plus 2 plus 2, which I think you know is 10. Okay, let's finish this up. There are some formulas. You don't have to memorize any of these yet. But I think you may already know number 1. That's exactly what we just did. It's just c plus c plus c plus d plus c. How many times? N times. So c times n. Notice all of these begin with k equals 1. So what this is saying is if you have, like for number 3, if you have this, k equals 1 to 10, that means it's 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5, 6, 7, 8, 9, 10 squared. Instead of adding all those up, you could use this formula and just plug in a 10. So this would be 10 times 11 times 21 over 6. Would give you the answer rather than add them all up. So it's a quick way to get sums of some common summations. Yes? And you don't have to memorize these yet, although I think you may already have this one, and you will have to memorize number 2 by the end. Because we're going to talk about that next time specifically, or time after next. Some properties. This C is a constant. I want you to think about this as just factoring out the constant, just like you would out of any sort of sum, you could factor out a constant multiple. For 2 and 3, does this make sense that this is kind of considered distributive property? And it does work for summations. So let's see how we'd use these for things that might get a little bit complicated. Like A, how many terms are there? There's 26 terms here. Now I know you could do this problem by just figuring out what each one of those terms is and adding them up. You could do that, can't you? I'm sure you can. But let's use the properties from above to see how we can streamline this process. First thing I'm going to do is use distributive property. There's no common multiple in there, so I'm going to distribute this and make this. And I'm going to leave off the decorations here. Just make sure at the end to finish it. What can I do with that 3? Now, 3 is a multiple of that argument, so I could go ahead and pull that out. So 3, I will put the accoutrements on there now. K equals 1 up to 26. Minus 7, because I'm going to evaluate. That's why I'm putting these on now. Okay, so this first one is going to be 3 times what? I know 26 numbers. I'm here, do you see it?
26, 27, 2.
So 26 times 27 over, do you all see where that came from? That is number 2. If you're adding to the first 26 terms of just K, 1 plus 2 plus 3 plus 4 plus 5, all the way to 26. You don't have to do that. You can put it into this formula, 26 times 27 divided by 2. So that's the first part. And then how do we do that second part? 26 times 7. You could probably visualize that. 7 plus 7 plus 7 plus 26 times. So minus 7 times 26, 26 times 7. And I do expect you to simplify. What simplifies here in this first one? The 2, of course, simplifies, leaving us with a 13. And then you can just type that in your calculator. Did anyone already do that? Okay, I trust that you can do that. The results will be the sum of, what do we start with here? Was it -4? plus -1 plus. Do you see what I'm doing here? I could do it slowly that way, write all 26 terms out, or I could trust these work. Yes.
If we're going to put it in our calculator anyways, we still the same.
I'm not intense from it. I want to see some sort of simplification.
Oh, so we still.
Use your best judgment. I'm really looking for the answer at some point. But you're right. If it's a calculator problem, then just type it all into your calculator. Go ahead and do B. Using the tools from this page, please. Check with your neighbor when you're done or stuck. I'm going to be calling one more person for this.
But yes, I got it.
It's ready. Use this one.
So basically, you just.
And then like just looking at this. No, I know, I started getting ahead of this.
Oh, you.
It's kind of fun.
Yeah.
Well, one, eventually two, but that's it. Okay, 2 and 4 are so interesting that they're almost the same thing. Did you get it? I need some help. Kimmy, can you help me with this, please?
I first broke it up into, the sum with the K square plus.
Yeah.
Sum 4. And then I used the formula. K squared and 1 that's it.
Okay,
I didn't multiply it out slowly, but it's.
Good.
16 times 29 over 6 plus 14 times 4.
14 times 4. Are we good with this? Thank you, Kimmy. Right, the path to the end is clear at this point. And you didn't have to add up 14 terms, which is kind of nice if you have access to those formulas. And again, you don't have to memorize any of them except the first one, and eventually, soon enough, the second one, and you're going to love it. I hope. Please take a moment to discuss with your neighbor, what did we do today? What are some things that are important for you to retain from this lesson?
Yeah. Yeah.
That's basically. Yeah, it's a plus, right? It's also.
Like. Does this charge at all?
Yeah, it works. It doesn't register immediately, but when you go to your seat, it'll.
Oh, yeah, it works.
I missed a shit. Which one?
Okay, so I'd like to hear, Holden, what's important? What do you need to hold on from this lesson?
Can I give you a really simple answer?
Sure.
Just 2 words, sequences and summations.
Oh, okay, that's the overall arching idea. Okay. Sequences and summations. Sophia C, what do you have to remember from this lesson? Nice. Okay. Amir, what's something else you have to remember from this lesson? How to read sigma. Oh, and thank you for saying, yeah, sigma notation. I think I mentioned summation notation. Sigma notation is another way of saying the exact same thing. And Christine, was there anything else?
Using like the different formulas for each respective question.
Nice, perfect. Ladies and gentlemen, great job today. I'll see you on Thursday. Did you like it? You like this discrete stuff so far? A little different.
Wait, will we get our 10% off?
I'll give it back